Good morning students. So today we are going to start a new chapter, chapter number 3, the nature of matter. So in this chapter you are going to learn about the properties of matter, the different states of matter, explanation for the existence of 3 states of matter and effects. But before that you should start with the warm-up activity given in your book. So in standard 5 you have learnt about matter. So there is an activity. You have to write the name of any 10 things in your day-to-day life and classify them as solid, liquid and gases and describe in one line. Like if you are writing water, then water is a liquid. Why? Because it doesn't have any shape. So you see many things around you and all these things are made up of substance. Okay, like trees, air, etc. You can touch some substances like trees, but you cannot touch some like air. So all these things or the substances are made up of matter. Then what is matter? Matter is anything that can be perceived by the senses. Okay, matter occupies space and can neither be created nor be destroyed. Okay, so it is made up of one kind of particles called substance and it can be distinguished from one another on the basis of its physical and chemical properties. Okay, see, as we know that all materials body take up some space. How we know that? If you keep this small diary, see, it will take some space now in the notebook. So all materials take up some space and the amount of space occupied by your body is called its volume. And if you will weigh anything, that it will have some mass. So what is mass? Mass is the measure of the quantities of matter. So from these 2 points we conclude that anything that has mass and it occupies space is called matter. Now the question comes to your mind, what is matter made up of? So matter is made up of tiny particles called atoms and molecules. So these particles are so small that you cannot see or a human eyes cannot see. Okay? So they cannot be seen by human eyes. So depending upon the arrangement of these molecules, matter, there are mainly 3 states of matter: solids, liquids and gases. So before going to that, there are 2 terms which you should know. Now see in this figure, you can see these tiny particles. So these tiny particles are the molecules. And if you will see more closely, all the molecules have some gaps between them. These gaps are called as intermolecular space. Now what is intermolecular space? So it is the space between the molecules of a substance. So there is a force that binds the molecules of this of any substance. That force is called as intermolecular force of attraction. So what is that? The force that binds the molecules of a substance. Okay, so after discussion of properties, now we'll see the different states of matter. So matter 3 states: solid, liquids and gases. This happens because of the space between the molecules and intermolecular force of attraction. So as you can see, in solids, the molecules are very closely arranged. Okay, so the gap is very low. In liquids, the gap is little bit more than the solids. Okay, and if you will see the gases, then the molecules are arranged far away from each other. That means the gap between the molecules is more. So if you will see the characteristics of solids, then solids have a definite shape, mass and volume. Why this is so? Because the gap between the molecules is very less. So the intermolecular force of attraction is high and they cannot be moved. Okay. Then see here, experiment shows a solid has a definite volume. So a wooden block is tied with a rope and it is dispersed. See, every reading shows 200 ml. Even if we change the shape of the container. So that shows that solids have a fixed volume. Okay. Then all the solids have a definite shape, size, mass and volume. Okay. So if you will see here, the block has a constant mass. So this experiment, if you will weigh a block or any solid substance, it will show certain mass. Okay. Now see, this is pen. A pen is a solid. So if I try to compress the pen, then what will happen? It won't be compressed. So solids are incompressible. Why solids are incompressible? Because the molecules are tightly packed together and the intermolecular force is strongest. That makes it almost firm and incompressible. Okay. Then the solids have high density. The amount of matter contained per unit volume. So density is more in solids, since solids do not diffuse. If I'll keep the pen is solid, the book is also solid. So if I'll keep the pen on the book, it won't diffuse. Then you see, this is the arrangement of liquids, molecules in liquids. So liquids do not have a fixed shape but a definite volume. Why? See, a quantity of liquid, that is 200 ml, is poured in different shaped containers. If you will see that it takes the shape of the container due to its molecular arrangement. Now liquids have a fixed volume. Okay, so here you can see the liquids have a fixed volume and a fixed mass. Okay, so you can measure the mass of the liquid and they will have a fixed mass. Then liquids have less density than the solids. Why? Because there is more increased gap. So when there is more gap, then there is less intermolecular. Now let's see the properties of the gases. So as you can see, this figure shows the arrangement of the particles of gases, and the particles are very far away from each other. So you will see that it has maximum space between the molecules. So it won't have any definite shape or size or volume here. And compared to the solids, it has, and liquids, it has the weakest force of attraction. Okay, so the particles of gases move in any random direction. See, gases occupy space. So if we will put the empty glass in a beaker full of water and you will turn the glass, you will find the bubbles escaping. So the air inside the tumbler will be displaced by the water, and so it shows that the gases occupy space. Similarly, the gases will have a mass. So if you will weigh the balloons, filled with air, it will weigh more than the empty balloons. And gases have no definite volume or shape. Okay. So that we can see in our daily life, that air has no definite shape, no? It is everywhere, so it doesn't have a definite volume too. Now let's see the changes in the state of matter. So matter exists in the three states: solids, liquids and gas. So what happens when the matter changes from one state to another and back to its original state? This is called interconversion of matter. So this change can be brought about by the two factors, temperature and pressure. Okay, so let's take a common example like ice. So when we keep ice outside, what happens? It gains heat from the environment and changes into water. Again, when we heat water, then what happens? It changes into vapors. Okay, so when we cool this vapor, then again it will change into water, and when we freeze this water, then again it will change into ice. So this is called conversion of matter. In nature, water cycle, okay, shows the change of water from one state to another. It clearly shows that matter can be converted from one state to another and back to its original form. Okay, now let's see the change of solid to a liquid. So the process is called melting. So what happens when we keep ice outside? Then it gains heat from the surroundings, and as a result it changes into water. This entire conversion occurs at a constant temperature. So this constant temperature at which a solid changes into a liquid is called its melting point. Okay, melting point of a solid is the measure of the strength of the intermolecular forces between its molecules. Okay, so when the water changes back to ice, so this process is called freezing or solidification. Okay, so what happens when you put water inside the freezer? Then the movement of molecules slows down as it loses the energy, and then what will happen? A stage will be reached when the movement of molecules becomes so slow that the water changes into ice. Again, this happens at a constant temperature, and this is called freezing point. Now let's see the change of liquid into a gas. So when we boil water on a stove, then what happens? The water gains the energy from the heat of the gas, and it starts to take the temperature, and as a result it starts to boil. After a certain time, what happens? The molecules gain so much energy that they tend to move faster and faster. Then the gap between them increases, and the molecule starts changing into the gaseous state. This process is called evaporation. Okay, the similar to the melting and freezing, boiling also occurs in a constant temperature. So this temperature is called boiling point. Now in your book, the table 3.3 shows you the difference between the boiling and evaporation. Okay, all the take-up breaks and the lesson are your homeworks, and you will also write the terms you need to know. Okay, I hope all is clear, and if you have any doubts, you can ask in the classroom.